So this video looks at the harder examples for integrating with partial fractions. So looking at question 3 on page 26. I'm not going to do all of question 3. I just want to talk to you about the fact that they haven't given us the factors on the bottom of the fraction. So it's sort of just working through the quickest way of reaching those factors. The recommendation that I'm sure you would all agree with is to use your calculator to identify the roots. Okay, in this case, we have roots of x equals a half, and also plus and minus 2i. So the half tells us that we've got one linear bracket. The plus and minus 2i tells us that we've got a quadratic bracket that we cannot factorise. So the half could give us x minus a half as a factor. But now we need to just use a little bit of inspection. We've got 2x cubed here, so x minus a half is going to be better written as 2x minus 1, because that will generate the 2 for here. So that's going to give me one factor. I then need to think about the plus and minus 2i. So if I have minus 2i and x plus 2i, if I expand that, I will get x squared plus 4. So therefore, the denominator, 2x cubed minus x squared plus 8x minus 4 can be written as 2x minus 1 and x squared plus 4 as the factors. And now those as denominators lead us into doing partial fractions in the same way that we did partial fractions in example 2. So I'm not going to take this question any further. What we are going to do, however, is come on and look at a quartic example. We need partial fractions. And in this case, we've got x to the 4 plus x over x to the 4 plus 5x squared plus 6. And I can factorise the bottom. I'm going to be producing 2 brackets with an x squared at the start of both. So we have x squared and we have x squared. The 6 will give me a 3 and a 2, both of which need to be positive to generate the 5x squared in the middle. So we have 2 quadratic brackets, and we need to have them in the format that will allow us to deal with them as partial fractions. Now, I've got a quartic divided by a quartic. That is going to generate a whole number answer and a remainder, and the remainder will have these 2 fractions involved. So the form of my partial fraction is going to be the constant, which we'll call a, plus bx plus c on top plus 3 plus e on top of the x squared plus 2. So as you can see, my partial fraction work for this is going to be a little bit more onerous. However, we are using the same method. So x to the 4 plus x is going to be equal to a times by both the brackets. And the bx plus c times x squared plus 2 and dx plus e times by x squared plus 3. In terms of coming up with the values for our unknowns, I'm going to use the method of equating coefficients. And I'm just going to work through them all systematically. So x to the power of 4. I have a 1. And I'm going to get an x to the power of 4 from these two multiplied together. So that's going to equal a. So we have our first coefficient. X cubed. And they're all only on the left. I am going to get an x cubed term from both this bracket and this bracket. So I am going to get, from here, I'm going to get bx times x squared, which is going to give me b. And from here, I will have dx cubed, x squared, 0. I'm going to get, from here, I'm going to get a 2x squared and a 3x squared. So that's a 5a. Then I'm going to get a cx squared and an ex squared. Considering the x's, none here, 1 on the left-hand side. I'm going to get 2 times bx, so that's 2b, and 3 times, so that's d. And then last but not least, the constants. 0 on the left. 2 times 3 gives me 6a. From this bracket here, we will have a 2c, and from here, a 3e. Now I'm going to use my calculator to help me, or do it manually, whichever's easiest, and come up with some partial fractions. So to begin with, let's have a look at the b's and the d's. So we've got 0 equals b plus d, and we've got 1 equals 2b plus 3d. Those give me b as -1 and d as 1. I then have 2 further equations. I can sub in for the a. So that gives me 0 equals 5 plus c plus e, and 0 equals 6 plus 2c plus 3e. And from those I will get e as 4 and c as -9. I can then sub everything in and do the integration. So we have 1 plus x. No, I need to get the numbers the right way round. Let's have x. So we'll take d and e. We're going to do these first because I've got a positive x. So we've got x plus 4 divided by x squared plus 2. And I've got a minus b and a minus 9. So we'll make the whole fraction minus. And we will have x plus 9 over x squared plus 3. And I now integrate those. I have methods for all of these. I need to split the fractions. So we have x over x squared plus 2. We have 4 over x squared plus 2 minus x over x squared plus 3 minus 9 over x squared plus 3. So I can work my way through. That will go to x. That will give me a log. That's in the form of an arctan, a log, and an arctan. So my integration gives me x plus the half of log x squared plus 2 plus 4 over root 2 arctan x over root 2 minus the half log x squared plus 3 minus 9 over root 3 arctan x over root 3 plus the constant of integration. And there we have our integration result with partial fractions for a fraction involving quartics.